All right. So as review, remember that there are actually two answers to every square root. The square root of 16, give me the two answers. 4 and -4. Why? Why is -4 an option? Right, because -4 times -4 is indeed 16, so we're okay. But in this book, whenever you see this symbol, that little radical symbol like that, you're going to say, we're just trying to make life easy, right? Just give me the 4. So this is the square root of 16, and you're going to say it's 4, knowing that there are actually two different square roots, okay? So that's why it says the square root of 16 is equal to 4 only. You'll need to come back to this as a question in your homework. And half of the class is going to raise their hand and say, I don't understand what this means. And I'm going to say, go back to the very first page of the lesson. We've underlined it. Okay. So I would like note the question in your homework. Cube roots. Okay, by the way, is it okay to have a negative out front of the square root sign of 17? Yes. Is it okay to have the negative sign under the square root sign? Is that possible? No, because there are no two numbers that make a negative if you do. Okay, but how about with cube roots? Can I put a negative under the cube sign? Yes, because -3, -3 times it all together, you have an odd number of negatives, and so you can indeed get back a negative, right? We learned that yesterday, or we remembered that. Okay, so there is only one. When we're talking about cube roots, there's only one answer. Okay, so when I talk about the cube root of -27, there's only one answer of -3. All right. I'm just going to jump right down here. Let's go. What is the square root of 49? Fast. 7. What is the cube root of -64? We know it's a negative. Don't use a calculator. We just made a cube root list. Was it on there? Let's do it again. Okay. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed? 64. So indeed, this answer is -4. All right, how about the fourth root of 10,000? Now, what does the fourth root mean? I need something times itself 4 times in order to get the 10,000. What would you guess that number would be? 10. Yes, 10. Think about it. 10 times 10. Yes, this is 10. All right, how about the fifth root of 1 over 32? Oh, for heaven's sake, fifth root. I got to make a fifth list. Okay, 1 to the fifth is 1. What is 2 to the fifth? 32. So 1 to the 5 is 1, and 2 to the 5 is 32, and that's probably the only one you actually need to know. So when I see this symbol over here, I'm thinking about the fifth root of 1 and the fifth root of 32. Just do them individually. What do you get? What's the fifth root of 1? 1. What's the fifth root of 32? 2. Done deal. So you just take them apart and do it individually. All right, how about the fourth root of -16? The number times itself 4 times, it will give you a -16. I got a couple head shakers. Adrian, how come you're shaking your head?
A negative times negative 4 times.
Exactly, right? Forget the number, just look at the sign. You can't get the sign back. So this is, I'm going to write undefined, or non-real, or, yeah. Okay? How about 2 times the cube root of 125? What is the cube root of 125? Does anybody know? Let's go back to my list. Here's my cube root list. What's 5 cubed? Oh, so the cube root of 125 is actually a 5. Is my answer 25? No, my answer is 2 times 5. Remember that 2 in the front. This 2 here is multiplying whatever the cube root of 125 is. Okay? Cube root of 125 is 5. Times it by 2, you get an answer of 10. Now, do you have a calculator? Could you put it in there? Yeah. All right, turn the page. This now teaches you how to use your calculator to do the fourth root. So if you take out your graphing calculator, I want you to hit the math button. Mia, can you watch Kenzie? Can you watch and show her? Okay. Same thing, Evan, can you watch Isaiah's? Isaiah, can you turn around and show him your calculator so you understand what you're doing? Okay, when you hit the math button, do you see the cube root sign under the math button? It's like number 4 or something. Do you see it? Come on, talk to me. Yes? Okay, so what if I wanted the fifth root? Is there a fifth root button where the index is a 5? No. So, but, let me show you what you can use. You're going to use this little button here. The one that has an X on it. Is there an X on one? Okay, stop. Go back. Can you hit quit? Second function, quit. Is it a quit?
You can push
The second function mode gets you to quit. So second function, it takes you back to your blank screen. Agreed?
or clear.
Or clear. Get back to your blank screen. So second function mode is quit. Okay, everybody's got a blank screen? Okay, if you want to put the fifth root or the fourth root or the 27th root, you have to put the root that you're going to ask it for first. So if I was doing the fourth root of 10,000, you have to put a 4 on the blank screen. So type in a 4. Then you go to your math button and choose number 5, which is the X with the little radical sign. Okay? So now you should have something that looks like this. It should have a 4, then it should have a thing like this with an X on it, and now you can type your 10,000 in there. Okay, everybody do that and get a 10? You good? Okay, so this is how you use your calculator, so it's very important. Okay, so that's how you get that extra root. Okay, so with your calculator, I want Summer, Maya, Ashlyn to do A. I want you girls to give me B. I want you, this row here, Hannah's row, to give me C. I want you guys to do letter D. Go. Find me the answer for those. Yes, sir.
May I borrow your graph?
Yes, you may. Sorry about that. I should have done that first. Here you go. Oh, you got an error. Who's got an error? You have this 7th root. Did you put a -2187 in there? Did you get an error? You shouldn't. Oh, okay. Let's get your answers first. I'll come back to you. Hold on. Question D. Did you get 6/5 or 1.2?
Yep.
How did I know that? I didn't get that off the top of my head. That's crazy. How did I know it was? No, because I took the cube root of 216, 6. I took the cube root of 125, 5, and then I converted 6/5 into 1.2. Okay, but on your calculator, you can put in, go get the cube root. That one's easy because it's already set for you. Then you can just go 216 / so on your calculator, people, you would go like this, get your cube root sign, then it would go 216 over 125, all under the radical, hit enter, and it would give it to you. Okay? All right, let's go back to C. Right here, what did you guys all get? -45. Okay, so you went, did you type it in just like it was? Did you do the fourth root first? What did you do then?
I did -3 times 4 root.
Okay, so she went -3, she put her times symbol in. Then she got the 4 on her screen, then she went and got this button, correct? And put in 50625.
Would that work?
That's a great, perfect way to do it. Absolutely. Yep, that's a great way to do it. The other way to do it is to hit your fourth root first, get your answer, and then go times -3. Okay, so just for a fun fact, Which negative button? Do you know that you have 2 negative buttons on your graphing calculator? You have 2 minus buttons for this line that goes horizontal. You have 2 of them. One is a subtract, and one is a negative. So what your problem was here in this group is you might want to use the negative button. You did, okay. You have to use, okay, so everybody look up here for a minute. Evan and Isaiah. On this question here, some of them got an answer and some of them got error. Everybody do it. Everybody do it right now. Stand up if you get the answer. The 7th root of negative 2187. Okay. Put your arm out if you got an error. Okay. Guess what your problem is? You can sit down. Guess what your problem is, error people? You put the wrong sign in. You know now?
No.
So did you get it right?
No, I don't know what that is.
Oh, it's okay. So right below the 3 is a negative button.
It's in brackets.
It's in brackets. So that's the one you have to use. By the way, you have to use that every time it's at the beginning of a number. So even this one would have to be that little symbol. So if you ever get an error, go check your subtract sign and make sure you use the negative sign and not the subtract sign. Okay, and how about the 5th root? So what is the answer to that one, by the way? Huh? Negative 3 is the answer to this one. How about the answer to the 5th root of 1024? 4? Okay, good. Moving on. Okay, here's a few definitions. Okay? I'm just going to tell you what this is. Look at this symbol, know the words. Ready? Isaiah, this is called an index. That tells you which root you're looking for. This sign is called the radical sign. And the number under the radical sign is called the radicand. Radicand. Radicand with a D on the end of it, radicand. Okay? By the way, lawn does not have a D on the end of it. Just saying. Sorry. Go out and mow the lawn. It's not a lawn.
Who says lawn?
Well, I did when I was a very little girl, and I just met an adult who says lawn. I'm like, it's not lawn. It's just lawn. Okay, but radicand has a G on the end of it. Just saying. There's a D. Radicand. Okay. All together, this whole contraction thing is called a radical. Okay? It's a radical. This is a radical. Okay? Got it? Get it good? Okay, now here's a very important note. When the index is not written, when we don't write an index in, we're going to assume it's a square root and it's a 2. Okay? When the index is not written in the radical, if you don't see one, we're going to assume there's a 2. Just a plain old square root like we always have had before. Okay, that's not changing in our life. And of course, the index is the number of times the radical must be multiplied by itself to equal the radicand. Okay. You on it? Questions? All right. So let's go right to B. Right here. Letter B. I don't see a number in the index. What is it? It's a 2. What's the radicand? 50. Okay, let's go back to A. What's the index? Quick. What's the radicand? All right. C. What's the index? What's the radicand? Good. What's the 5 doing? Multiplying that answer, right? Whatever it happens to be. Good. Okay. Next, going on. Do you know that the square root of 9 to the square root of 4 is equal to the square root of 9 times 4? Do you agree with that? Did you learn that in your homework? Uh-huh. Because this is 3 times 2, which is an answer of 6. Nice. This is the square root of 36, which also has an answer of 6, so we're all good. Okay? How How about when we divide them? Is it true? Well, this becomes 3 over 2. If I divide, square root of 9 is 3, divided by square root of 4 is 2, which is 1.5. If you took the square root and you took it of, type it in your calculator just for fun, do that. Square root of 9 divided by 4. Do you get 1.5? Oh, we do. So you have the 1.5 here as well. So take a little note, take a little look, to remind yourself. They work for multiplication and division. Individually or together is the same answer. You put them together in one statement, like all under the radical, or you can do them individually. We're all good. What about when you add? Did you discover that in your homework? What's the square root of 9? Square root of 4. What does it add to? 5. That is not the same as the square root of 13. I'm sorry, it's just not the same. Square root of 13 is like, well, it isn't even 4. It's 3 point something or other, right? Okay, same thing happens when you subtract. They're not equal. Okay, so when you have radicals, you can do them individually or together when you multiply and divide. There are no rules for addition and subtraction. You just have to do them individually. Okay? So there it is. The product or the quotient of the roots of two numbers is equal, but the sum is not. All right. So look at this. Do you think it's true that square root of 3 times the square root of 6 is the square root of 18? Is that a true statement? Owen says yes. He's right. Because we're multiplying. We're good. Everything's good when you multiply. How about part B? What are we doing? What operation? Division. Are the rules the same for division? Yes. The square root of 20 divided by the square root of 10 is the square root of 2. That is a true statement. We're good to go. What are we doing over here on C? Is this a true statement? No, it is not. There are no rules for addition and subtraction. Are there rules for multiplication and division? Yes, they're simple. It's just what you think. You can kind of ignore the radicals and just put your answer into the radical. So what do you suppose the answer is for class example number 6A? For this one, root 8 times root 3. What do you think that's going to be? Can we do this together when we're multiplying? Yes, we like multiplication. It's just square root of 24. Done deal. See it? Multiplication is good. How about part B, root 7 times 3? Just root 21. So you're kind of ignoring the radical sign. You're just kind of doing it like we've always done it. We just put a radical over the answer. Okay, how about root 50 divided by root 10? Root 5. Mm-hmm. Okay, how about on C? You see how there's a double radical sign there? You can always work on the inside. That's the way God does it. He works on the inside out, right? So you could always actually just go eliminate that square root of 100. Like, let's just fix that. We don't like it. Do you like it? I don't like it. What is the square root of 100? Okay, can we just make life simpler? So we're going to copy, and we're going to copy that one down. But where I have the square root of 100, I'm just going to put a big old 10 instead. Am I still equivalent? Like, make sure you're equivalent, right? You didn't change the value, and copy the bottom. So there's an example of copy everything down, all the symbols, just change one thing. The square root of 100 became a 10. You all right with that, Sophie? Ashley, you good? Now do the math. We're doing division. Am I allowed to just call that, just do the math, call it root 5? Yeah, absolutely. Okay. Here comes another one. Let's go backwards. I have a whole number under that radical sign, like it's all one piece. Let's put it into the product, that means multiply, of two radicals. That's what I'm supposed to do. What would you choose to go in those symbols? 7 and 11. Let's do this one. Product of radicals. So two radicals multiplied together. What will go in there? 9 and 3. Can I tell you, it doesn't really matter which order you put them in, but one will make your life easier. Put the 1, do you guys hear how you just said 9 and 3? Is one of those a perfect square? On the square list? Put that one first. Hint, hint. Put it first. I'm going to put the 9 there and the 3 there. Doesn't really matter, but it will matter in a minute. So put the one that's nice, that has a nice square root, put it first. Okay, 40, what do you wanna do? 4 and 10, put the 4 first. Any other options for 40? 8 and 5, neither one of those have a perfect square, so I don't care where you put it. Yeah, so there's a couple options. Any other options? Say it again. Any other numbers that multiply together get 40? 2 and 20, okay. So there's lots of options, right? Lots of things, lots of different answers that it could be. You could even put 40 in one, but don't do that. Okay, good, I'm done. Any questions? Okay. What I'm gonna do right now though is I'm gonna give you a quiz and then you're gonna come back and finish this homework, okay? Make sure on this is not on your quiz, what we did today. This has to do with factor trees, greatest common factor, lowest common multiple. Tell me what you know about that stuff. How do you find the greatest common factor? Who remembers? Do your tree. Okay, we did the tree. Now, how do you do the greatest common factor between two numbers?
I always forget which is which.
Yeah, everybody forgets which is which. That's why I'm asking.
Is that the one?
How do you know? What word should you be thinking about in greatest common factor?
Lowest.
The lowest, so it's going to be a smaller number than what you think. What's the other word you need to talk about? Common factors. That's common pieces. It's going to be a small number, and it's going to be the common pieces that they have. So how do you do that? Well, they both have a 5. Write it down. They both have, well, this one has 3 2s, this one has 2 2s. I'm just going to write down the ones they have in common, 2 2. You with me? Remembering? Okay, how about the lowest common multiple? What's the word that's standing out to you in lowest common multiple? Multiple means what? Many, big. Okay, how do I get the lowest common multiple?
So you first do the biggest number, you write all of those down, and whatever that number doesn't have, the other one has. Doesn't.
Yeah, so do you hear what she said? Someone repeat what she said. Over here. Courtney, what's the lowest common multiple? What did Angelina just say?
So we take like all of the factors in the one, and then we take other extra factors.
Do you know what she's saying? Can you say it a different way? I take all the factors and then look at your other numbers, and any factors that aren't in your list, put them in. Right? Okay, let's go. Let's see if we remember how to do that now. We've reviewed slightly.
So during this whole year, we will never take your calculator away.
I am not going to take your calculator away this entire year.
Okay, awesome. Good to know.
Oh my goodness.
Extras? Okay, do your best, and of course, don't take too long. If you don't know how to do it, turn it in, try, but don't spend forever. Well, it's a learning moment.